Hello! So we have all of our factoring techniques down. There were quite a few of them. I think there were 8 if I remember right. So this section, it sums it all up. It says, okay, we know now that we have 8 factoring techniques. But the problem is, what if you're given a random polynomial and someone just says, hey, factor this, but you're not really sure what method to use when? It gives you a general guideline on how to tell what method to use. And then, so we'll practice for all these examples here on this page. And then I think you'll get the hang of it. It's not too bad to pick it up. So let's just kind of maybe read through the directions here. Or, the general guideline. It says, so let's just say you're given a random polynomial. You can look at the example here, part A, just for an example. I look at part A, it's 10a squared minus 810. And at first I'm kind of lost. I say, oh my gosh, there are so many techniques. Which one am I going to use here? So let me see. Step 1 in the general factoring strategy here, it says, if there's a common factor, you want to factor it out. And be sure to include that in your answer. So I look at part A, and I do see that both terms, the 10a squared and the 810, they have a common factor of 10. So that might help. If there was no common factor, then I would just move on to step 2 in the general guideline. I'd say, all right, that didn't work, let's try something else. But that'll help. But even though I factored a 10 out, that might not mean I'm quite done. Once I factor the 10 out, what's left inside the parentheses might be able to be factored further. So I'm going to have to keep reading here. Step 2 says you want to count the number of terms. So depending if there are 2 terms left here, 3 terms, or 4 terms, you're going to do maybe one of 2 different things. So if I look at what I'm left with, after I factor the 10 out, there are only 2 terms, an a squared and then an 81. That's 2 terms, so I must be looking at part A. So if there are 2 terms, it says you're going to use the difference of squares, the difference of cubes, or the sum of cubes. So I guess the first thing to look at is, looking at my 2 terms here, a squared and 81, are those squares or are those cubes? Well, I think the power on a kind of gives it away, right? That's something squared. That's not something cubed. And then 81, that's something squared. That's not equal to something cubed. So we must be doing what step 2 part A says, the very first thing. You're going to use difference of squares. Alright, and I think we'll be done with this problem at that point. Alright, let's see. So I got to remember to leave the 10 outside. Don't lose that. That should be part of your answer. But once I factor that out, if you remember way back when we learned about difference of squares, when you factor difference of squares, you're going to have one of the factors with a minus and one with a plus. It doesn't have to be in that order. It could be the plus and then the minus. That part doesn't really matter. But the terms that go in the first place of the parentheses, or the left place, you ask yourself, what can you square to get a squared? Well, it'd be a, right? A squared is a squared. And then the thing that goes in the second spot here is, what can you square to get 81? That would be 9, since 9 to the second power is 81. And that's it. I look at these factors that are left over. I've got a 10. I mean, I can't really break that down any further. A minus 9, I can't break that down further. That doesn't really fit any of our factoring techniques. A plus 9, similarly, nothing I can do with that. Alright, I think we're done with part A. That's a good one. Okay, let's try part B. So I look at part B, and if I start back, in the general factoring strategy at step 1, step 1 says you want to see if there's a common factor. I definitely do not see a common factor. Like, I notice the z squared and the 10z have a z in common, but the 25 does not have a z. So there's no variable in common. The second and the third terms, 25 and 10, both have a common divisor of 5, but 5 doesn't really divide or factor out of the first term. I think in this second example, part B, there's no common factor. So I can kind of skip step 1. Now I'll move on to step 2. Step 2 says now you want to count the number of terms here. We got z squared, 25, and 10z. There are 3 terms. That must mean instead of looking at part A, like we did in the other one, we're going to look at part B of the general factoring strategy. So it says there are 3 terms, and it could be one of 2 methods. It depends, like it says. If the coefficient of the leading term is 1, then you're going to use the method we learned from section 5.2. It's not official, but I like to call that the easy method, because you can just come up with the answer right away in one step. But if the coefficient of the leading term was not 1, then you're going to use that FOIL method, or grouping. If you remember, that's the one where you go make an x and then say, what's a times c, and what multiplies to that but adds to b? all that complicated stuff. But in our example, I noticed that the leading term, the one with the highest power, is z squared. He has a coefficient of 1. So we got lucky. We can use this easy method because if there's a coefficient of 1 in front of the leading term, which if you remember, leading term just means the one with the highest exponent, then you can use the easier method, which is not too bad. I think we got lucky there. Oops. We will be using the easier factoring method, as described in step 2, part B here. Alright, but you know what you notice is that the three terms we have here in this trinomial, they're not in the right order. So, because they're supposed to be from highest power to lowest power, right? Descending power order of powers. I see a z squared. It should be the 10z next, and then the 25. So it's kind of a subtle thing that they might throw in there at you, that you not only have to worry about the general factoring strategy that you have up at the top, but also, are my terms in the right order? But now that they're in the right order, I think we can go ahead and start that easy factoring method where you just kind of think, well, what times what can make z squared? Well, it'd have to be a z and a z. And then what? The next thing is, what numbers do I need? What numbers multiply to 25 but add up to 10? So numbers I think of are 5 and 5, since 5 times 5 is 25, 5 plus 5 is 10. And that's a perfectly fine answer, but as we've seen before, if you see that two of your factors are the same, since z plus 5 occurs twice, I'm going to write it as that thing squared. It just looks more complete that way. And like I said, it's good to get used to that because we'll be using that fact later on to solve equations and things like that. So far so good. We got 2 down. Let's try this third one here, part C. So I'm going to start with step 1 again in the general factoring strategy. There is no common term between these three terms here. 8t squared, 31t, and negative 4. 31's a prime number, right? So I don't think anything's going to divide into those three coefficients. And they don't have any variables in common. So okay, there's no GCF. So now step 2 says, count the number of terms. And we've already kind of commented that there are 3 terms here. There are 3 terms, but the coefficient of t, or of x, or whatever variable, is not 1. So we're actually going to have to use, as it describes in part B, since there's a coefficient of the leading term, we're going to have to use the FOIL method, or that grouping method. This is probably the one that I would, be least excited to see. So I have to make that little box, say, well, 8, that's going to be my A, 31's B, negative 4 is C. So the first thing I want to do is figure out what's A times C. A times C, that's 8 times negative 4, that's negative 32. And then B is the middle term, that's positive 31. And now I have to figure out what are these two numbers that have a product of negative 32, but a sum of 31. That seems complicated, but the first thing I think of is, how about 32 and negative 1? Because 32 times negative 1 is negative 32 like we need, but 32 plus negative 1 is 31. So that one seemed like it was going to be a tough, I don't know, the 31 kind of scared me. That's like kind of a larger number and it's prime. I got a little bit scared, but actually this problem is not going too terribly. But at this point, once you find those two numbers, if you remember, you want to rewrite the first term exactly the same, 8t squared. The last term exactly the same, negative 4. It's just the middle term is going to be broken up, and it's not going to be written as 31t. It's going to be something t and something else t, where those somethings are the numbers you just found. The 32 that I just wrote inside that little kind of X shape there, and then the other one was negative 1. So yeah, these numbers here, the 32 and the negative 1, now correspond to the coefficients of t that the middle term is broken up into. And now we're going to factor by grouping. If we have room in this little box here, kind of split it down the middle and then decide, what do the first two terms have in common, 8t squared and 32t? Actually, they have quite a bit in common. I think 8t can be factored out of both, huh? That's quite a bit. Alright, if I factor 8t out, t plus 4 would be left. Alright, and if I look at the third and the fourth term, negative 1t, or you could just write negative t, negative 1t or negative t, and negative 4, they really have nothing in common. There is no greatest common factor. But we said you have to factor something out, so if there is no greatest common factor, you can think of it as a 1, since 1 divides into anything. But not only 1, I have to actually factor a negative 1 out, since the sign above it, the middle sign, was a negative. I have to keep the sign the same as I kind of follow the steps down. And if I factor a negative 1 out, let's see, negative 1 times what would be negative 1t? Well, that would be t. And then negative 1 times what is negative 4? That would be positive 4. And that's a good sign that this big term on the left and the big term on the right, they have the parentheses in common, t plus 4. That means I should be able to factor it out, and then the leftovers will go in the second parentheses. The leftovers from the first big term, you have 8t, and the leftovers from the second big term, you have negative 1. So there it is. That's the final factorization there. And I guess in really complicated problems, you probably wouldn't see it in this class, but maybe in the next class, you might want to check to see, are both of those done factoring? I don't think I can factor the first guy anymore, the t plus 4. That's not going to happen, right? 8t minus 1, I can't factor that any further. So it's probably a good idea to check. It might be in more complicated problems. You might see in your next class that one or both of the remaining factors, once you factor it once, can be factored again. It's probably pretty rare, but it's not a bad idea to be safe and check it out. Let's move on to part D. Okay, I'm going to start over the general factoring technique. First step said is that if there's a common factor, then you want to factor it out. And I do notice that the three terms we have here, x to the third minus 24x squared plus 144x, they have an x in common. I was hoping for more, but no, that's really all they have in common. And if I take an x out, that kind of just brings everybody's power down by 1. It'll be x squared minus 24x plus 144 with no x because I factored it out. And now looking at what remains inside, I see x squared minus 24x plus 144. If I move on to step 2 of the general factoring technique, I'm supposed to count the number of terms. I have 1, 2, 3 terms, and there's no coefficient of x squared, you notice. Or, the coefficient is a 1. So now I can use that easier factoring technique. It won't be the complicated one with the x because there's no number in front of x squared, thankfully. So I'm going to leave the x outside. The inner things, I know it's going to be an x and an x, or whatever your variable is. And all I have to do is think about what are the numbers that multiply to the right number, 144, but add up to the middle number, negative 24. Well, 144 is a large number, and I got kind of scared at first. Like, oh my gosh, there are so many things that can multiply to 144. But when I see 144, the first thing I think of is 12 times 12. And I think that'll actually work. I just got to make sure they're both negative in order for them to add up to negative 24. I think that's it, because negative 12 times negative 12 is 144. Negative 12 plus negative 12 is negative 24. And then again, since those are the same factor, x minus 12 is twice, I'm going to write that as that guy squared. So that'll be our final answer there. I can't factor that any further. That's kind of as good as it gets. Alright, so far so good. I think we're doing pretty good here. Let's try this next one, part E. So, okay, the first step said you want to see if there's a common factor. I don't think there's anything in common here. I thought at first there was a y in common, since the first three terms have a y, but the last guy does not have a y. There's no common factor. Now I'm moving on to step 2. I count the number of terms. There are 4 terms. This is the first time we've seen that. And notice if you go back to the steps, it says part C, if there are 4 terms, you're going to factor by grouping. And I think when we first learned factor by grouping, I mentioned that that's kind of my favorite method because you always know when to use it. If you count the terms and there are 4 terms, easy peasy, it's always factor by grouping. So I'm going to do like we learned with factor by grouping and kind of split it right down the middle and then try to see what can I factor out of the first 2 terms. Between y to the third and 3y squared, they have a y squared in common. And if I factor that out, I'll be left with a y plus 3. Alright, that works. How about we'll try to see what the third and the fourth terms have in common. Negative 4y minus 12. Well, a 4 divides into both of them, but I better factor a negative 4 out because the sign above it was negative. And if I factor a negative 4 out, negative 4 times what is negative 4y? Well, that'd be a y. Negative 4 times what is negative 12? That would be a positive 3. And you know we're doing a good job because they have the same thing in parentheses, y plus 3. And then the leftovers will go in the second parentheses. Y squared was left over once I factored y plus 3 out of the first term, and then negative 4 is left over once I factor y plus 3 out of the second term. Alright, and it may seem like we're done, but this is one of those instances where one of the factors we have left at this point can be factored further. Y plus 3, there's not a whole lot you can do with that. There's no common factor. It doesn't look like, it's two terms, right, y and 3. So according to the general factoring technique, if there are two terms like we have here, y plus 3, the only way to factor it further would be either if they have a common factor, which they don't, or it could be a difference of squares, difference of cubes, or sum of cubes. But y and 3 are not squares of anything or cubes of anything. That's why that guy, nothing's going to happen with that guy. I'm just going to rewrite him the exact same way. But the second factor, the y squared minus 4, that's actually a difference of squares. Because it's something squared minus something squared. Alright, and if you remember, difference of squares factors into one with a plus and one with a minus, or a minus and then a plus, it doesn't matter. And then you ask yourself, okay, what can you square and get the first term? Well, it'd be a y, because y squared equals y squared. And then what can you square and get the second term, 4? Well, it'd be 2, since 2 squared is 4. Alright, and that's as far as it goes. The remaining things that we have there, there's three things here, and they're all binomials. If any of those three factored further, like it says in the general factoring technique, since each of them has two terms, the only hope we have of factoring them is if one of them is a difference of squares, which none of them are since you have no square terms here. There's no something squared. Difference of cubes, or sum of cubes. But these terms, y, 3, y, negative 2, y, and 2, those aren't squares or cubes of anything. So that's how you know you're done. There's nothing else I can do. I've kind of broken it down as far as it can go. Alright, let's try part F now. Part F, the first, again, all these problems, the first thing you're supposed to think of is there a greatest common factor? And this guy does happen to have a greatest common factor. I'm going to think about it. I know they're both even numbers, 98 and 18, so 2 goes in for sure. Can 4 go in? Nah, 4 doesn't go into 18. I'm trying to think of the biggest thing that goes in. You think 18 can go into 98? Let's try it. 18 times... 5? No. 4? No. Okay, 18 times 5 is 90, and that's too small. And I think if we try 18 times 6, it would be too big. Alright, 18's not going to work. You think 9? No, 9 doesn't go into 98. Maybe 6. Because I know 6 goes into 18. Let's try 6 into 98. Nope. Okay, that's not going to work either. I think it's just a 2. Man, I was hoping for more than that. Oh well. I guess maybe it'll work out better that way for some reason. Alright, I'm going to factor a 2 out. It doesn't seem like a lot, but that might make the rest of the problem easier to work with. So 2 times what is 98? That's 49. T squared. And then 2 times what is 18? That's 9. Alright, now I notice actually that makes the inside more clear as to what to do. This is a difference of squares in here. It's something squared minus something squared. Because 49 is 7 squared, t squared is t squared, and 9 is 3 squared. Alright, so this is another difference of squares. I'm going to kind of set it up here. The 2 kind of hangs out. He's waiting for the end of the problem to come. There's 2 parentheses, one with a plus and one with a minus, or vice versa. And then the thing that goes in the first spot of both parentheses is, what can you square and get 49t squared? Well, it'd be 7t, since 7 squared is 49 and t squared is t squared. And then what goes in the second spot is, what can you square to get 9? Well, 3. 3 squared is 9. Alright, there it is. It should be 2 times parentheses 7t minus 3 times parentheses 7t plus 3. Beautiful, and none of those can break down any further. The 2 in the front, there's nothing you can do to factor that. The 7t minus 3, that could, since it's a binomial, the best chance you have of factoring that further is maybe it's a difference of squares, or the difference of cubes, or the sum of cubes. But 7t and 3 are not squares or cubes of anything. And kind of similarly for the last factor, 7t plus 3, that would have to be one of those sum of cubes, difference of squares, but neither of those terms are cubes or squares. So we know we're done with that one. There's nothing else we can do there. So we're about halfway done here. We're doing pretty good. Let's try the next one, part G. This one looks kind of scary because we have big numbers. But I think if you think of the first step, see if there's a greatest common factor, that's going to make the problem a lot nicer, a lot of times. If I notice that these 3 terms, 20x cubed, negative 4x squared, and negative 72x, they not only have an x in common, I think 4 goes into all those numbers as well. So this time the greatest common factors are actually a lot more interesting than it usually is. Alright, then 4x times what is 20x to the third? That would be 5x squared. And then 4x times what is negative 4x squared? All I need is one more x. Since I have one x and the 4, I just need one more x to get to the 4x squared. And then 4x times what is 72, or negative 72x? Well, I'm not really sure. I'm not really familiar with 4 divided into 72, so I'm going to try it. Or, 4 times what is 72? Let's see, that would be 18, I guess. Huh, okay. Alright, so it must be minus 18, since you want to multiply 4x by something and get a negative value. Alright, so what we're left with in the parentheses there, 5x squared minus x minus 18. And then I think that's going to factor further. If I kind of start over, or go to step 2 of the general factoring technique and think, alright, what kind of technique am I going to use here? Well, it has 3 terms, 5x squared, x, and 18. So it's either could go the easy factoring route or the hard factoring route. It all depends on, is there a coefficient of x squared other than 1? Unfortunately, there is. This 5 kind of ruined it. If that 5 was a 1, it would be really easy at this point. But that 5 kind of ruined it. Thanks a lot, buddy. So you have to do that factor by grouping thing, or the x method kind of. I think that's what a lot of students call it. It's just easier to remember that name. The x method. And that kind of reminds you what it is, too. You make a little x. Then you say, what's a times c? Well, a is 5 and c is negative 18. Oh, man. What's that? 18 times 5. Whew. 90. Oh, my gosh. But it's negative 90 because it's a positive 5 times a negative 18. So you're looking for what multiplies to that guy, but adds up to the middle term. The coefficient of the middle term, you're thinking, well, what's the coefficient of x here? It's negative 1. That's your b, the middle coefficient. So I want to know what are the numbers that multiply to negative 90, but add up to negative 1. So let me see, 90, I guess the first thing I think of is 9 times 10. There are other ways to break 90 down. That's 45 times 2. But there's no way those are going to add up to negative 1. And I'm thinking 9 and 10, those would work. Or the other way around, you could write 10 and then 9, whatever. But which one would have to be negative? Well, they have to add up to a negative 1. That means the larger one's probably going to be negative, right? That way 9 and negative 10, that will add up to negative 1. And 9 times negative 10 is negative 90 like we want. Well, those will be our numbers that we want, 9 and negative 10. Alright, this looks good. I'm going to try to remember to keep the 4x outside, not lose it, even though I'm not really doing anything with it right now. The next step, if you remember, is you want to rewrite the first term, 5x squared, exactly the same. The negative 18 at the end, exactly the same. But the x in the middle, you want to split it up into 2 terms. Each of them with an x variable, or whatever variable is on that term. But their coefficients are these new numbers you found, the 9 and then the minus 10. And then I should be able to factor by grouping here. Let me see. Oops. Watch out. Okay, I'm going to group the first 2 terms together, factor out their greatest common factor, and then we'll do the same with the second group of terms. And that 4x in the front is just kind of along for the ride. He's waiting to see what happens. So the 5x squared and the 9x, the only thing you can really factor out is x. That's about it. If I take an x out, 5x plus 9 would be left. And then from the third and the fourth term, negative 10x and negative 18, I think only negative 2 is all I can take out. And make sure you take out a negative because the sign above it was negative. If I take a 2 out, 5x plus 9 would be left, which is perfect because we said that the things in the parentheses should be the same. Here we have 5x plus 9. Okay, that's the same as this guy, 5x plus 9. If I think of this as one big term and this was one big term, I can factor that 5x plus 9 out of both of those terms. And then kind of the leftovers, the x from the first term and the minus 2 from the second one will be left over. And you just don't want to forget your 4x that was already there. And there it is. I think we cannot go, we can't really get better than that. That's as good as it gets. Whew, so there it is. 4x times 5x plus 9 times x minus 2. And none of those can be broken down further for kind of similar reasons to what we were talking about earlier. The 4x is, it's just a monomial. We don't have any factoring techniques for monomials. It's just one term. 5x plus 9, since it's 2 terms, along with the other factor, x minus 2, those are both binomials. The only hope they have of factoring further would be if either of them is a difference of squares, difference of cubes, or a sum of cubes. But neither of those has any squares or cubes in it, so that's not going to happen. Although the 9 and the 5x plus 9, he looks like a square. That sounds funny, huh? Like some person looks like a square. Anyway, but his friend, the 5x, he's not a square, so that kind of ruined it for the 9. Thanks a lot, guy. Let's try part H now. So part H, this one kind of scares me. This is the type that scared me at first. I look at it and I say, okay, this is a trinomial. and the leading coefficient is not 1. Oh man, so do I have to use this x method where I have to make this x like we just did? No, we actually don't in this one, because once I realize there's a greatest common factor of 4, I'll factor the 4 out, and the leading coefficient will all of a sudden become 1. So it'll make a problem that seems scary and like, oh, I have to use that x method which takes forever. Once I factor this guy out though, it'll be good. So if I take a 4 out, 4 times a squared makes 4a squared, 4 times 5a will make the 20a, 4 times negative 36 makes the negative 144. And then now I realize, oh, you know what, now that I factored that 4 out, what's left is one of those easy factoring techniques. All of a sudden, the leading term's coefficient is a 1 instead of a 4 like I thought it was. So this is going to be the easy technique where I just say, alright, there are the variables, the numbers I want, multiply out to negative 36, and add up to 5. Well, when I see 36, I think of 9 times 4. And I think that would work because 9 and negative 4 would make 5 if you add them together. I think that works. Yeah, 9 times negative 4 is negative 36. 9 plus negative 4 is 5. So there it is. And none of those factors factor any further for the same reasons we've mentioned in the previous one. They're binomials. Neither of them looks like difference of squares or difference of cubes or sum of cubes. Alright, let's try part I. So part I, if I look at that one, I think, is there a common factor? No. Nothing divides into 4 and 85. Oh, sorry. Nothing divides into 4 and 81, so that's just not going to work. They don't have a variable in common. So there's no common factor. Now I'm going to move on to step 2. Step 2 says, now, okay, count the terms. I have 2 terms. And that means it's either going to have to be a difference of squares, but that one I could actually rule out right now. That's not going to happen because difference of squares has to have a minus in between. That's why it's called difference of squares. So that was one option. Okay, if it's not that, it could be difference of cubes. But that's also out for the same reason. Difference of cubes means it's supposed to be a minus sign. But we have the sum of 2 things. So the only hope we have left is the last guy. A sum. Okay, that's a good thing. But it's the sum of cubes as the very last resort. But you notice 4z squared, the first term, that's not a cube, right? That's not something to the third power. And actually, neither is 81. This isn't going to work either because these are not cubes. So it's more like we were given the sum of squares, you know? Sum of squares, because 4z squared is something squared, 81 is something squared, and we've discussed before that the sum of squares cannot be factored. It's only the difference of squares that can be factored. So you'd have to have a minus sign in between in order for this to not be prime. So this must be a prime polynomial. Ugh, after you factor a lot of polynomials, then you kind of forget that some of them are prime, and you kind of, I don't know, that's how I feel. I kind of freak out, like, well, how do I do this? I can't figure it out. Just keep in mind there are some that cannot be factored, and, you know, once in a while you get kind of lucky in a way, because that means I don't have to do a lot of work. I just say, it's prime, no need to do any work for me, easy peasy, no problem. So we're almost there. Let's try part J. I see 3 terms here, and I think there's a greatest common factor of x to the third. That's kind of the lowest power I see. But not only do I want to factor an x to the third out, I'd also like to factor a negative out. Because if you remember, we said if the leading term has a negative in the front, you want to factor that out, along with whatever the greatest common factor is. Because that'll make whatever's left in the parentheses easier to factor. If I didn't take a negative out, what's going to be left in the parentheses would be really hard to factor. Alright, now, how does negative x to the third factor out? Negative x to the third times what is negative x to the fifth? Or a positive x squared. And then negative x to the third times what is negative 14x to the fourth? Well, I need a 14 to get the 14. I have 3 x's, but I need 1 more to get the 4 that I see in that term there. And then the last guy, okay, negative x to the third times what is negative 49x to the third? Well, that guy's got the x to the third, he's just missing the 49. And it'd have to be positive, because if I put a negative 49 there, it would be a negative x to the third times negative 49, which would make a positive 49x to the third, but we want a negative. So I think all the terms inside are negative, now that I've factored a negative out with the x to the third. Alright, now that I look at what's inside the parentheses now, I'm going to count the terms. There are 3 terms here. So it's either going to be that easy factoring technique, or the kind of more difficult one with the x method. Thankfully in this one, the coefficient of x squared is a 1. I could just go ahead and start setting this up and writing x's there, and now all I have to do is think, what kind of numbers multiply to 49 but add up to 14? Well, the only thing I think of when I see 49 is 7 times 7, and those happen to add up to 14 as well. 7 plus 7 is 14, 7 times 7 is 49. And we're pretty much done. It's just, since I noticed that two of the factors are the same, x plus 7, I'm going to write that as x plus 7 squared. Just to kind of finish it off and make it look nice, and I don't know, it does look a lot cleaner when you write it like that, rather than two separate factors. That was kind of a difficult one, or it looked difficult, but it wasn't, once we kind of started it, it wasn't that bad. How about part K? Looking at part K, the first thing we're supposed to do is say, is there a common factor? I do see that these two have a 4 in common. 4 divides into 4, and it divides into 64. So if I take a 4 out of 4x to the 4th, the x to the 4th would be left. And then I'd say 4 times what is negative 64? That would be negative 16, since 16 times 4 is 64. And looking at what's left inside the parentheses, if I count the terms, there are 2 terms. So it's either going to be, like we listed kind of up here for part, what was that, part I. It's got to be one of these three, the difference of squares, the difference of cubes, or the sum of cubes. So looking at that guy, the power doesn't look like a second power or a third power. But I think I can make a fourth power look like something squared. I can't make a fourth power look like something to the third power. And then 16, that kind of gives it away as well. 16 is 4 squared, or to the second power. But 16 is not something to the third power. I think this guy's going to be a difference of squares. Even though the x doesn't have a second power, I can kind of force it to have a second power. So okay, there's 4 is outside, kind of just along for the ride. I know difference of squares factors into something with the minus, something with the plus. The things that go in the first spot of both parentheses are, what can you square and get x to the 4th? Will be x to the second power. X to the second power times itself would be x to the 4th. And then what goes in the second spot there is, what can you raise to the second power or square and get 16? That would be a 4. Alright, we got that. Now I'm kind of going to scan each of my factors, each of these factors, and see if I can factor further. The 4 is done. This very rightmost one, x squared plus 4, that's a sum of squares. So those are both something squared, but there's a plus inside, which we know is prime. So that one can't be factored further, but the middle one happens to be a difference of squares. Another one, we just factored a difference of squares once. Now we're going to do it one more time. So yeah, he happens to be a difference of squares. That means he can factor further. So alright, we're going to keep the 4 the same because it can't factor further. The final factor, x plus 4, can't factor further. But this x minus 4x plus 4 can be split into 2 factors. Same kind of thing with the minus and a plus, since it's another difference of squares. The thing in the first spot will be, what can you square and get x to the second power? Well, of course that would be an x, because x to the second power is x squared. And then the thing that goes in the second place is, what can you square to get 4? Well, that'd be 2. Whew, and I think that's as good as it gets. You can't factor that any further. That cannot get any more complicated. So there it is. That's probably one of the hardest ones you'll see in this section. Yeah, something like that. So just keep in mind, once you factor once in one technique, that might not mean you're quite done. There might be one more thing to do. We're on the last one now. Let's look at this guy. Part L. I want to first see if there's a common factor. At kind of first glance, it looks like there might be, because the first 2 terms have an x in common, but not the last guy. And then the third and the second terms have a y in common, but not the first guy. So there are no variables in common, and 3, 13, and 10 have nothing in common to factor out. So there is no greatest common factor. I have to move on to the second step of the general factoring technique, and then say, looking at these 3 terms here, how many terms are there? There's 3 terms. So that means that this could either go the direction of the easy factoring technique or the difficult one with the x. But I can tell this is going to be the difficult one with the x because the leading term has a coefficient of x other than 1. Or sorry, a coefficient of x squared other than 1. So I'm really going to have to do that kind of difficult method, the x method. So I have to do a times c. Remember, a is the coefficient of the first term, 3, and c is the coefficient of the third term. So I'm multiplying 3 times negative 10, that's negative 30. And then I just carry down b. b is the middle term, 13. So I need to find 2 numbers that have a product of negative 30 and a sum of 13. let's see, I'm going to kind of write it out. If I can't immediately think of it, I'll do like we did in previous sections. 30 is 1 times 30, but there's no way those are going to add up to 13, no matter which one I make positive and which one I make negative. 30 is also 2 times 15. Okay, if I made one or both of those negative, could they ever add up to 13? I think they could, huh, if I put a negative on the 2. That would work. Negative 2 plus 15 is 13. Negative 2 times 15 is negative 30. There we go, those are the ones. And I think at first on this one I looked at negative 30 and I thought, how about 3 times 10? At first I thought, oh, because look at 3 times 10 is 30. And also 3 plus 10 is 13. But notice the signs don't work. Although 3 plus 10 is positive 13, that's true. But 3 times 10 is positive 30, and you need it to be negative. And if you made either of those negative, like the 3 maybe, they're no longer going to add up to 13. So those look like they were going to work, but they're not. The signs kind of ruin it. That's why this other factorization worked for the signs and for the numbers. Negative 2 and 15. So now I'm going to rewrite this trinomial. We keep the first term the same, 3x squared. The third term the same, negative 10y squared. But the middle term I'm going to split up into 2 terms. And keep in mind, even though this guy's got two variables, x and y, that just means that both of the terms I split it up into will have the same variables, x and y. So it's not really a big deal, just copy the exact same variable or variables that you saw. And its coefficients will be the numbers I just found, negative 2 and then the plus 15, if I can fit that in there. There we go. So it looks complicated, but just trust the process. We're going to factor by grouping now. Split that down the middle. If I look at the first and the second term, I think the only common factor they have is an x. But that's still something, so I'm going to factor an x out. If I factor an x out, what's left over? 3x minus 2y is what would be left over from those terms. And if I look at the third and the fourth terms, 15xy minus 10y squared, well, they have a 5 in common. I can see that. 5 goes into both of those numbers. But they also have a y in common. I can factor not only a 5, but also a y out. And I'm factoring a positive out since there was a positive above it. Same sign. So, okay, 5y times what would be 15xy, 3x. Since 5 times 3 is 15, y times x would make the xy. And then 5y times what is negative 10y squared. I need negative 2 and another y to make the y squared. Alright, that looks good because the thing in the parentheses is exactly the same. 3x minus 2y. And the leftover from the first big term is an x. The leftover from the second term is a 5y. So there it is. And if I look at either of those terms, or those factors, those are both binomials. Those can't be factored further because if they could, they'd be either a difference of squares, which I don't see any squares there, or difference of cubes, which I don't see any cubes, or sum of cubes, and I still don't see any cubes. That's how you know you're all the way done finally. So I think that was kind of a good mix of all types of problems. And hopefully that made it more clear on kind of what method to use and how everything works. Now the next section we'll actually use this to solve equations. And the equations, it's good we went over this because the equations, they won't tell you what factoring technique to use. So it's kind of good to know if you have a mix of all kinds of factoring problems, what technique to use depending on how it looks.